Imagine living in a world where you could walk from New York to Morocco without the need for a boat or a plane. That's the world of Pangea. Picture this: a colossal landmass stretching as far as the eye can see. Mountains, plains, and forests all rolled into one, teeming with diverse life forms. This is not a scene from a high-budget fantasy film, but a recollection of our very own planet, Earth, around 300 million years ago. This massive landmass, a supercontinent, was known as Pangaea. Pangaea, a term coined from the ancient Greek words pan, meaning all, and Gaia, signifying Earth, was a singular, unified supercontinent. It was an amalgamation of all the continents we know today. Pangaea was an immense landmass surrounded by a superocean, Pangaea, a vast, endless body of water. The concept of Pangea might sound fantastical, but it's grounded in rigorous science. The theory of Pangea was first proposed by the German meteorologist and geophysicist Alfred Wegener in the early 20th century. Wegener, studying the similarity in fossils found on different continents, hypothesized that these continents must have once been connected. His theory, though initially met with skepticism, gradually gained acceptance as more evidence supporting it surfaced over the years. The existence of Pangea answers many questions. Ever wondered why the shape of South America fits almost perfectly with that of Africa? Or why similar plant and animal fossils are found in regions separated by vast oceans? These puzzles find their solution in the existence of Pangea. But the story of Pangea is not of unity alone. It's also a tale of separation, of fragmentation. Over time, due to forces deep within the Earth, this massive supercontinent began to break apart. The landmasses we know today as continents gradually drifted away from each other, shaping the world as we see it now. So how did this supercontinent come to be, and why did it break apart? Stay tuned as we unravel the mysteries of Pangea. The birth of Pangea was no overnight event. It was a slow yet dramatic process that took millions of years. Picture this: the Earth, over 335 million years ago, was a vastly different place than the one we know today. The continents, as we recognize them, did not exist. Instead, the Earth's crust was made up of numerous pieces, known as tectonic plates. Now, these plates aren't stationary. They're constantly moving, albeit at a pace slower than the growth of your fingernails. But given enough time, these slow movements can result in significant changes. The birth of Pangea was one such monumental event, brought about by the relentless dance of the Earth's tectonic plates. As the plates moved, they collided, separated, and rearranged. Some of the oceanic plates were subducted or forced beneath the continental plates, resulting in volcanic activities and the creation of mountain ranges. On the other hand, some continental plates collided head-on, causing them to crumple and fold, creating even more mountains. These collisions and movements were the sculptors of the Earth's landscape. Over hundreds of millions of years, these movements brought all the landmasses together into one giant supercontinent we now know as Pangea. The name Pangaea, derived from the ancient Greek words pan, meaning all, and Gaia, meaning earth, perfectly encapsulates this phenomenon. It was a world unlike any other. A single, uninterrupted landmass surrounded by a vast global ocean, Pangaea. Now imagine a world where all continents are fused into one. The climate and the biodiversity would be significantly different from what we are familiar with today. Pangea was home to a unique blend of life forms, with species being able to migrate and interact across vast distances without the barrier of oceans. Pangea was not just a massive landmass, it was a world teeming with life and diversity, but it wasn't meant to last forever. The shifting tectonic plates that brought the continents together would eventually pull them apart. But that's a story for another time. For now, let's bask in the grandeur of Pangea, the mother of all continents. Just as Pangea was formed, so too was it destined to break apart. Imagine a giant jigsaw puzzle, its pieces fitting together in a perfect harmony, only to slowly and inexorably start drifting apart. That's the story of Pangea, our Earth's last supercontinent, which began to fracture around 175 million years ago. Now you may wonder, what caused this colossal breakup? The answer lies deep beneath the Earth's surface, in the roiling, churning heart of our planet. There, intense heat from the core creates convection currents within the semi-fluid layer of the mantle. These currents exert tremendous forces on the crust above, causing the tectonic plates to move. In the case of Pangaea, these forces started to pull the supercontinent apart. This process, known as continental drift, wasn't a sudden catastrophic event. Instead, it happened over millions of years, at a pace so slow, it's hard for us to even comprehend. Think of it this way. The rate at which your fingernails grow, that's about how fast these tectonic plates move. But over the vast timescales of geological history, even such slow movement can produce dramatic changes. As Pangaea split, it formed two large landmasses, Laurasia to the north and Gondwana to the south. These two continents were separated by the newly formed Tethys Sea, but the breakup didn't stop there. Over the next 100 million years, Laurasia and Gondwana continued to fracture and drift, eventually forming the 7 continents we know today. This process of continental drift also gave birth to the Atlantic Ocean. As the Americas moved westward away from Eurasia and Africa, a vast body of water formed in the growing gap. Today, the Atlantic Ocean continues to widen by about 2.5 centimeters per year. That's about the speed at which your hair grows. And it's not just the Atlantic. All around the world, tectonic forces continue to reshape our planet. The Himalayas, the tallest mountain range on Earth, are still growing as the Indian plate collides with the Eurasian plate. The Pacific Ocean is slowly shrinking as its floor is subducted or pulled under the continental plates that surround it. These movements have profound impacts on our world. They cause earthquakes and volcanic eruptions, create mountain ranges and ocean trenches, and influence climate and weather patterns. The world as we know it today is a direct result of these tectonic forces. So while Pangaea may be long gone, its legacy lives on. The breakup of this supercontinent set the stage for the world we inhabit today, a world of diverse continents and oceans, teeming with a rich variety of life. The separation of Pangaea was a monumental event in Earth's history, one that continues to shape our world to this day. The continents may have drifted apart, but they carry with them the memory of their shared past, a testament to the ever-changing dynamic nature of our planet. Pangaea may be long gone, but its legacy is still very much alive. Even though this supercontinent disintegrated over 200 million years ago, its impact echoes through time, shaping the world as we know it today. When Pangaea existed, it significantly influenced the global climate. With most of the landmass concentrated at the center of the planet, the vast expanse of ocean surrounding it resulted in a much drier climate inland. This led to the evolution of species adapted to desert conditions, many of which still walk the Earth today. The formation of Pangaea also played a crucial role in the distribution of life on Earth. As the continents pulled apart, organisms found themselves isolated in new environments, leading to the development of distinct species. The isolation of Australia, for instance, led to the evolution of unique marsupials like the kangaroo and the koala, creatures found nowhere else on the planet. But Pangaea's legacy extends beyond the animal kingdom. It also had a profound impact on plant life. The supercontinent's breakup set the stage for the dispersion of flora across the globe. The ginkgo tree, for example, is a living fossil from the era of Pangaea. Once widespread across the supercontinent, it has survived in various corners of the world, standing as a testament to a bygone era. Pangaea's influence even extends to human evolution. Africa's separation from South America created the Atlantic Ocean, which would later become a significant barrier for human migration. This isolation allowed for the development of diverse cultures and civilizations, shaping the course of human history. Pangaea's story is a powerful reminder of the relentless force of plate tectonics, the slow yet unstoppable movement of the Earth's crust. The breakup of this mighty landmass demonstrates the Earth's dynamic nature, its ability to change and evolve over unimaginable timescales. From the formation to the breakup, the story of Pangaea is a testament to the dynamic and ever-changing nature of our planet. The legacy of Pangaea lives on, not just in the shape of our continents, but also in the diverse life forms that inhabit them and in the intricate tapestry of human civilization. The continents have been on the move since the breakup of Pangaea, but where are they headed next? We dive into this question to close our journey through time. Geologists predict that the continents, in their ceaseless motion, will eventually come together again to form a new supercontinent. This is not mere speculation, It's based on the study of tectonic plate movements, the very forces that birthed Pangaea and later tore it apart. Some scientists propose that in about 250 million years, a supercontinent called Pangaea Proxima could form. This is a fascinating idea, isn't it? The concept of continents merging and breaking apart in a seemingly endless cycle. As we've seen, the story of Pangaea is a fascinating journey through time. It reminds us of the incredible dynamism of our planet and leaves us wondering what the future might hold. Until then, keep exploring, keep learning, and never stop being curious about our incredible world.